The kinetic profile of 3I, Atlas, represents a fundamental departure from the interstellar baseline. While 1I, Oumuamua, arrived at 26 kilometers per second and 2I, Borisov, at 32. Atlas maintains a staggering arrival velocity of 60 kilometers per second relative to the Sunday. This doubled kinetic energy points to an origin within a high-velocity stellar population, far beyond the local dynamics of previous visitors. This is an outlier from a distant, ancient neighborhood. Hello, friend. Thanks for tuning in. Stay focused and trust the data coming in real time. If you want to be part of this mission, subscribe right now and leave the comment Atlas below. Write where you are watching from and the exact time, because from this moment on, you are part of the global observation of the unknown. Is less than break time equals 1 second is greater than we are observing a galactic elder. Based on its significant vertical excursion from the galactic mid-plane, I estimate the age of 3I, Atlas, at nearly 10 billion years. This trajectory places its origin firmly in the thick disk of the Milky Way, a stark contrast to the younger thin disk inhabitants we encountered previously. 1I, Oumuamua, was estimated at a mere 1 billion years old, and 2I, Borisov, at 1.7 billion. The temporal provenance of Atlas suggests it has survived the chaotic evolution of the galaxy for an order of magnitude longer than its predecessors. To traverse the thick disk and maintain such a vector implies a resilience that exceeds the structural limits of common ice or porous rock. While Oumuamua and Borisov were relatively local wanderers, Atlas is a relic from a deep temporal well, carrying the signature of an era when the Milky Way was still in its formative stages. The energy required to achieve this vertical displacement suggests a specialized delivery mechanism that remains unaccounted for in standard models of natural ejecta. Is less than break time equals 1 second. Is greater than the orbital geometry of 3I divided by Atlas is unprecedented in the history of solar system observations. Its measured eccentricity stands at a record-breaking 6.1. For context, 1I, Oumuamua, possessed an eccentricity of 1.2, and 2I, Borisov, reached 3.4. A value of 6.1 describes a path so hyperbolic it is effectively a straight line through our local space, showing almost no gravitational capture or significant deflection by the Sunday. This object is the most unbound interstellar visitor ever recorded. The extreme departure from a parabolic orbit indicates it was never intended to linger. It is a high-speed transit event. Such a high eccentricity combined with its massive velocity confirms that Atlas is navigating the gravitational well of the Sun with a level of kinetic immunity that dwarfs previous interstellar candidates. We are not looking at a captured fragment, but a projectile with a specific, unyielding vector that minimizes time spent within any single planetary system. This suggests the object was launched with a purpose that necessitates crossing vast interstellar distances in minimum temporal windows. Is less than break time equals 1 second. Is greater than Hubble Space Telescope imaging reveals a jet morphology that contradicts standard cometary behavior. Unlike the traditional dust tails of Borisov or the total lack of visible outgassing from Oumuamua, 3I Atlas exhibits a unique sunward anti-tail and a wobbly double jet structure. My analysis of the rotation data indicates a 7-degree wobble in its primary axis, a periodic instability that suggests complex internal dynamics. This is not the uniform sublimation of a dirty snowball. The sunward orientation of the material ejection suggests a directed release or a response to solar radiation that is not governed by typical thermal gradients. If this were a natural comet, the jets would trail behind the motion, Instead, they appear to interact with the solar wind in a structured, non-stochastic manner. This 7-degree axial variation could indicate an artificial stabilization system struggling with high-velocity thermal intake or a multi-component internal structure shifting under external pressure. The presence of two distinct jets firing in opposition suggests a symmetry that is rarely found in the irregular fracturing of natural ice nuclei. Is less than break time equals 1 second is greater than spectral analysis of the 3I divided by Atlas plume has identified a chemical signature that is biologically and geologically anomalous. The ejecta is remarkably rich in nickel, with a conspicuous, almost total absence of iron. In natural astrophysical environments, iron and nickel are typically found in predictable ratios due to nucleosynthesis and common planetary formation. However, this specific nickel-dominant composition mirrors high-performance industrial alloys utilized in advanced aerospace engineering for thermal shielding and structural integrity. This differs fundamentally from the water ice and carbon monoxide mixtures seen in 2I, Borisov and the unknown, potentially rocky or metallic substrate of 1I, Oumuamua. The exclusion of iron suggests a refined material origin rather than the chaotic accretion of a protoplanetary disk. We are measuring the ablation of a specialized surface, one that remains stable at temperatures where standard cometary volatiles would have long since dissipated. This is not cosmic debris. It is a processed material signature that points toward an intentional manufacturing process designed for high heat environments. Is less than break time equals 1 second is greater than the luminosity patterns of 3I divided by Atlas display a rhythmic 16-hour fluctuation that we have termed the heartbeat variability. While 1I, Oumuamua, exhibited extreme light curve variations attributed to its highly elongated, cigar-like or pancake-like geometry, the pulsations from Atlas are more structured and periodic. This 16-hour cycle, synchronized with the wobbly double jets, presents a variability profile that cannot be explained by simple geometric tumbling of an inert rock. The luminosity does not just fade and brighten, it pulses with a distinct regularity. This suggests an active internal process or a rotating surface with alternating reflective properties designed for a specific thermal or communicative function. Combined with a 7-degree axial wobble, the heartbeat variability implies a system in a state of controlled operation or a regulated decay of an active core. The precision of the 16-hour period is far more reminiscent of an automated system than the random rotation of a solar system fragment. This heartbeat is the clock of a persistent machine, maintaining its rhythm through the vacuum of interstellar space. Is less than break time equals 1 second. Is greater than I propose that the dust envelope surrounding 3I divided by Atlas is not a byproduct of sublimation but a self-regulating feedback loop. The optical depth of this veil remains remarkably close to unity, maintaining a precise balance between transparency and opacity. This characteristic suggests a design protective blanket intended to shield the central nucleus from direct solar radiation or interstellar erosion. In contrast, 2I, Borisov's dust, was a standard, messy byproduct of ice sublimation, and 1I, Oumuamua, was entirely clean, lacking any detectable shroud. The Atlas veil appears to adjust its density, a mechanism that could serve as a thermal regulator for a technological core. This is a borderline state of matter that serves a specific function. By maintaining an optical depth near unity, the object can manage its internal temperature profile with extreme precision, a trait unheard of in natural cometary bodies which tend toward chaotic, unmanaged outgassing until their volatile reserves are depleted. We are looking at an autonomous shielding system that responds to the proximity of the host star, is less than break time equals 1 second, is greater than the volumetric scale of 3i divided by Atlas, confirms it as a mission class object, with a nucleus estimated between 0.5 and 5.6 kilometers in diameter. Its mass is 3 to 6 orders of magnitude greater than the 100 meter scale Oumuamua or the sub-kilometer Borisov. This scale is sufficient to maintain long-term structural integrity across a 10 billion year transit through the thick disk. An object of several kilometers is not a mere scout. It is a platform capable of carrying significant payloads or housing complex, multi-layered technological systems. The sheer mass allows for the nickel-rich shielding and the self-regulating dust dynamics we have observed. As we process the final data streams, the conclusion becomes unavoidable. Atlas is the first truly large-scale interstellar visitor that demonstrates the hallmarks of intentionality, from its extreme velocity to its refined composition and regulated luminosity. We are no longer looking at the crumbs of a distant star system, but the artifacts of a civilization that operates on a galactic timescale. The data is clear. The only question is whether we are ready to accept it. Is less than break time equals 0.5 seconds, is greater than